Good afternoon. This is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. Today I am going to deliver a topic, three-phase induction motor. So three-phase induction motor is most widely used in motor industry. They work on a principle of electromagnetic induction. So due to the similarity in working principle of transformer, it is also known as a rotating transformer. They can run at essentially constant speed from no load to full load. The speed is frequency dependent and consequently these motors are easily adapted for speed control. So we prefer, it is the most preferred motor when large speed variations are required. So this is a stator of the three-phase induction motor. So we'll be having a stator. Stator consists of steel frame that encloses a hollow cylindrical core made up of thin laminations of silicon steel to reduce the hysteresis and eddy current losses. A number of evenly spaced slots are provided on the inner periphery of the lamination. The insulated conductors are connected to form a balanced three-phase star or delta connected circuit. And next is a rotor. Rotor is mounted on a shaft. It is hollow laminated core having slot on its outer periphery. The winding placed in the slots, we call this winding as a rotor winding, may be one of the following two types. It can be a squirrel cage rotor winding or it can be a wound rotor type. And next is a working principle of three-phase induction motor. The working principle of three-phase induction motor is based on the Faraday's law of electromagnetic induction, which is the same principle which is involved in the transformer. Hence, we call it as a rotating transformer. When a three-phase stator winding of an induction motor is energized by a three-phase supply, a rotating magnetic field gets set up which rotates around the stator at a synchronous speed capital Ns. The rotating field passes through the air gap and cuts the rotor conductors which are stationary, and EMFs get induced in every rotor conductor due to the relative speed between the rotating magnetic flux and the stationary rotor. The current carrying rotor conductors are placed in a magnetic field that is produced by the stator. So consequently, a mechanical force will be acts on a rotor conductor. So when a current carrying conductor is placed in a magnetic field, it will be experiencing a force. So here a mechanical force acts on a rotor conductor. The sum of mechanical forces on all rotor conductors produces a torque which tends to move the rotor in same direction as that of the rotating field. The rotor is urged to follow the stator. Rotor moves in the same direction of a stator, which is given by the Lenz's law. Next is the applications of three-phase induction motor. They are used for loads that require a constant speed. So where speed control is required, this three-phase induction motor is widely used. Typical applications of wound rotor or slip ring induction motors are crushers, plunger pumps, cranes and hoists, elevators, compressor and conveyors. And next is an important term is a slip in the induction motor. Slip is represented as S. S is equal to Ns minus N by Ns, where Ns is a rotating stator field, the speed of the rotating stator field, and N is a actual rotor speed. So Ns minus N by Ns. So slip is usually expressed as a percentage of synchronous speed. Ns minus N by Ns into 100 gives a slip. So the quantity Ns minus N is sometimes called as a slip speed. When rotor is stationary, this N is equal to 0 and the slip S is 1 or 100%. And next is starting methods of induction motor. A three-phase induction motor is self-starting. When a supply is connected to the stator of three-phase induction motor, a rotating magnetic field is produced and rotor begins rotating and the induction motor starts. At the time of starting, the motor slip is unity and stator current is very large. The purpose of stator is not just to start the motor, but it performs two main functions. They are to reduce the heavy starting current, to provide overload and undervolt protection. First one is a direct online starter. The direct online starter method of induction motor is very simple and it is economical. In this method, the starter is connected directly to the supply voltage. By this method, small motors up to 5 kilowatts rating are started to avoid the supply voltage fluctuation. Second one is the star delta starter. The star delta starter method of starting three-phase induction motor is very common and widely used among all the methods. In this method, motor run at delta connected start stator winding. Next is the auto transformer starter. Auto transformer is used in both the type of connections. Either it can be a star connector or it can be a delta connector. Auto transformer is used to limit the starting current of the induction motor. So that's all about the three-phase induction motor. General introduction, construction, application and starting method. And also we have came across a term called slip. Thank you.